Hi everyone, welcome back. So this is the last topic we're going to work on in chapter 2 of your textbook, and it's one on using formulas, and really this is just revision that we've worked on before. So just a reminder that a formula or a rule is just an equation that includes two or more variables, and it shows a relationship of different things and how they work together. So basically what that means is we can find the value of one variable if we know all of the other variables in the problem. So sometimes to do this though, we need to rearrange or transpose, remember that word? Transpose the formula to make a different variable the subject. That means get it on its own on the left-hand side of the equation. So you just have to really remember those terms. Transpose just means rearrange, and make the subject means get it on its own on the left-hand side. So we're going to look at a few different ways we can work with formulas here. So let's do that now. So the first one might be substituting. So in this case, we need to substitute the values into the following formulas to evaluate the subject. So the one we're working with is I equals mr squared divided by 2, and we want the answer for I when m equals 12.2 and when r equals 6.4. So first thing I'm going to do is substitute those numbers into our formula. So I, in this case, equals, so instead of m, I'm going to write 12.2, and remember these are actually times, and r squared. So we want 6.4 instead of r, and we're squaring that number, and it's all divided by 2. So let's simplify and get a bit further. So I equals 12.2. Now it's only the 6.4 that's squared here. 40.96 is what that would be. Use your calculator over 2, which now means we can find an answer for I. I equals 249.856. So in this case, it's literally just a matter of substituting in and simplifying for the answer. Okay, let's have another go at substituting into another problem. So this time Q equals the square root of 2gh when g equals 9.8 and h equals 11.4. So obviously if we know g and h, we're trying to find q. So in this case, q equals the square root of 2 times 9.8 times 11.4. I'm just going to extend that square root sign so it covers all of it. So the first thing we need to do is simplify that little sum that's in under the square root sign, because we need to do that first before we take the square root of the final answer. So q in this case, it's going to be approximate because it's an ongoing or recurring decimal, not recurring, but yeah, a decimal that keeps going, so we need to round it. So I've used the approximated equal signs here. Okay, so hopefully that's pretty straightforward for you. So in this case, we've been asked to find the unknown value in a particular formula. So to do this, we're going to substitute first, and then we're going to rearrange. Now, of course, you could rearrange first, but if you've got numbers that you're going to substitute in, it's often easier to rearrange once you've substituted those numbers because you've got less letters to work with. So while you're getting better at it, that's probably a good way to go if you can. So this question, m equals f over a when m equals 12 and a equals 3. So the unknown that we're working with here is going to be f, which is part of our right-hand side of the equation. So let's substitute in what we have and then simplify, rearrange, and solve. So 12. I'm going to put in for m. F has got to stay there because we don't know what it is, and a equals 3. So f is the top part of our fraction on the right-hand side, so we need to deal with the bottom of our fraction. So we need to multiply both sides by 3 to get rid of that divide by 3. So 12 times 3 is 36, which will leave us with f on the right-hand side, and all we need to do is just swap them around due to mathematical convention. We want our unknown on the left. Okay, so transposing or rearranging formulas. So this time we're going to transpose or rearrange without substituting anything in. We just want to rewrite the formulas so that a different unknown variable is the subject. So the first one, a equals 2 pi rh we need to transpose that formula to make r the subject. So that means we want r on its own on the left-hand side of the equation. So in this case, the right-hand side of our equation is 2 times pi times r times h. So we need to divide by everything that side of the equation that is not r, because if we do that, we'll just have r left, and we need to do exactly the same on the other side. So we are going to divide by everything that is not r. So a 2 pi r h, I'm going to divide by 2 pi and h. And I need to do the same to the other side. So on this right-hand side, things are going to cancel right down, and we will just be left with r, which is what we want. And of course, we need to rewrite so that our unknown is on our left-hand side, and the other side of the equation cannot be simplified in any way, so we just need to rewrite it as it is, and that's fine like that. Hopefully that makes sense. Now, question 2 in this section is much more complex. So in this case, we want to transpose t equals 2 pi times the square root of L divided by G, and we need to make G the subject. So it's going to take quite a few steps to get down to our final possible simplest answer. So this seems straightforward, but there's actually quite a bit involved here. So what we need to do first is, now G is on the right-hand side of our equation, so our goal is to get rid of everything else that is attached to the G and get it on its own. So what we need to do here is get rid of everything that's outside the square root on the right-hand side first. Because remember, it's just really being multiplied by what's in the square root. It's just that multiply sign is not written. So we need to remove what is outside the square root first. So I'm going to write quite a few explanations of what I'm doing here because it is a much more complex problem. So, and I'm going to write extra steps that you may or may not want to include when you get better at it, but until you are good at it, let's just write them all here. So we need to divide both sides by 2 pi. We're multiplied currently by 2 pi on the right-hand side, so we need to divide both sides by 2 pi. So t over 2 pi equals 2 pi square root. Now I'm going to use the curly L to hopefully make it clear, divided by 2 pi. They will cancel on this side, so let's write what we've got left. So we've got t divided by 2 pi equals the square root of L over G. So that's what we've got with here. Now our next step is to remove the square root sign, okay? So now we're going to remove the square root by squaring both sides. Remember, square and square root are opposite operations. So we need to square both sides to make that happen. Now I'm going to carry on down here because we're going to need a fair bit more space. So we need to square both sides. So I'm going to write that in brackets to show clearly what I'm doing. So the full amount of both sides needs squaring. So all of t over 2 pi needs squaring, and all of the square root of L over G needs squaring. Now, on the right-hand side, the square and the square root just cancel each other out. But on the left-hand side, that's not the case. That is going to all stay there. So we're going to be left with just L over G on the right-hand side. Now we're getting there. We need to get G on its own, but G is on the bottom of our fraction and not on the top of our fraction, so we actually need to get rid of the bottom of that fraction first. So we must move the bottom of the fraction first. Oops. Move the bottom of the fraction first. And to do that, we are going to multiply both sides to do this, okay? So we are going to multiply both sides by G. So G times t over 2 pi all squared is going to leave us with L. on this side. We've multiplied both sides by g. Now, we need to get rid of what is multiplied by the g so that we've got g on its own. So in this case, t over 2 pi all squared is multiplied by the g. So we are going to divide. So now we must divide by both sides by everything else except g. Because we want to get g on its own. Okay, oops, my L vanished. Okay, so we are going to end up with g equals L divided by t over 2 pi all squared. I think that vanished something, but it's still okay. So we can simplify this further. So we've got g on its own, which is definitely our goal, but we can actually simplify this further so we have a better expression on the right hand side. So let's do the squaring that's there. So in this case, we're going to have g equals L. Now, t over 2 pi all squared means every single thing in that bracket needs to be squared. So that's going to leave us with t squared over 2 squared is 4 pi squared. So all we've done is remove the bracket and actually done the squaring that is listed there. Now, we've got a fraction within a fraction. So what we're really saying is we want to divide L by the fraction. So I don't know if you remember fractions from when we did them, I hope so, but when we are dividing by a fraction, which is what we are doing here, dividing by a fraction is the same as multiplying by the inverse of the fraction. So what we're going to do is flip that bottom fraction and multiply that side by it so that we can simplify further. So g equals L times t squared, oops, no, we need to flip it, times 4 pi squared over t squared. Now, it's probably easiest to turn them both into fractions, and remember we can turn any number or letter into a fraction by putting it over 1. Now, multiplying fractions, top by the top, bottom by the bottom. So that is going to give us g equals 4 pi squared L over t squared. So something to remember here is that when we are multiplying, numbers always go first, just like we are when we write any algebraic expression. Remember, pi is just a number, it's just a special number. So 4 pi squared L over t squared is what g is going to equal, and that's as simple as it gets. So let's go quickly back up here. What you are going to do in the lesson is work through these problems in exercise 2H. And for our next lesson, which will be next week, you need to watch the Introduction to Linear Relations screencast for our next unit in the next chapter and take notes for that. All right, see you later in class.